go to sleep. Hello. At some point, aha! Hello. I'm here to talk to you about writing code by voice, and I hope you all are interested to see some demos. Good. A quick note on the content of this talk. You'll get the most out of this if you know just a little bit about how to program. If you don't have any programming experience, the first 3 minutes may be quite disorienting. They might be anyways. After that, things will slow way down and we'll take things step by step. So hang in there. Without further ado, I'd like to give you a demo of what it looks and sounds like to program by voice. Wake up, Emacs. Function fib, near slap, air becomes 0 slap, bat becomes 1 slap, state 4 in, under tail func range, near trailing col, air spam bat becomes bat spam air plus bat, slap, state if, air op mod 3 is equal 0, logical and air op mod 5 is equal 0, slap, func print, in string smash fizzbuzz, slap junk, state else if air op mod 3 is equal 0, slap func print in string fizz, slap junk, state else if air op mod 5 is equal 0, north junk third, sit find join lines trailing col, func print in string buzz, slap junk state else, func print air, slap junk junk state return air, disk, run Python, cross solo split wide cross buffer Python, Chris go top Python send buffer, cross say fib round 20, rush, center bottom, go to sleep. Thank you. Right, so what we just did there, or what I just did there, is implement Fibonacci, but along the way we're printing all of the numbers, except if it's divisible by 3, we print fizz. If it's divisible by 5, we print buzz. And if it's divisible by both, we print fizzbuzz. So hopefully that gave you some idea of what programming by voice looks and sounds like. Now I'm going to give you some context on who I am, how I got into this, and then we're going to break this down slowly. Buffer slides. So I'm Michael Arnzenius. I'm a computer programmer, and in about November of 2019, my hands started hurting. This is not uncommon among programmers. Heavy repetitive keyboard use can produce something called RSI, repetitive strain injury. And I'd had mild RSI symptoms for several years. Then in about 2 weeks, they went from mild to unignorable. And for about the next 6 months, I could not type for more than 30 minutes a day without being in quite noticeable pain. There are standard approaches to trying to solve RSI. Change your ergonomic setup, get a fancy keyboard, get a fancy desk, get a fancy chair, do regular stretches, do exercises to strengthen your wrists, and just take more breaks, which is generally a good piece of advice. I did all of these, and they did not work, or at least they didn't work fast enough. So I tried an extreme solution. I stopped typing. The tool I used to do this, slide next, is called Talon. I heard about it from a friend of mine who also couldn't type. And there are various other tools like this. I would call them user programmable voice control tools. Talon is the one that I know, the one whose community I'm embedded in, but there are other options like Dragonfly and Serenade. Dragonfly has the distinction of being entirely open source from the beginning. Serenade has now been open sourced. It was a startup. I think it's kind of defunct. I don't know what's going on there. Talon, the core is proprietary. It's funded on Patreon, but everything built around it is more or less open source. Anyway, wake up, slide next. Drowse. The structure of this talk is we're first going to go through a sort of voice commands 101. How do you define and use voice commands to edit text? Along the way, we're going to discover one of the many things that makes this difficult, which is latency. And then we're going to go through a series of increasingly powerful solutions to this problem of latency. I hope you like demos, because most of the rest of the talk is still demos. All right. Buffer demo. So how do you define a voice command in Talon? It's actually pretty simple. You say the thing you want to say, you put a colon, and then you say what you want it to do. By saving this file, which is inside a particular directory, my user scripts directory, I've just defined a voice command. Wake up. Hello, EMF. Blank. You can also define voice commands that are slightly more useful for actually editing text files. Oops, if I remember how to type. I could define these using my voice, but then I couldn't also talk to you. Delete this line. Undo that. Undo that. Go to sleep. Okay, so that worked, but it probably happened too fast for you to tell what was going on. So I'm now going to insert some delays in between each of these key presses to make it clearer what is going on. So here we are basically instructing Talon to press some keys on our behalf. If I can't do it, make the computer do it. So, wake up, go 3-step, go line 3, wake up, go 3-step, delete this line. Undo that. Drowse. So what's going on here is we're pressing the home key, which goes to the beginning of the line, the shift end key, which selects until the end of the line. We're pressing delete, which deletes the selection, and then we're pressing it again to get rid of the now empty line. And so by chaining together a bunch of key presses like that, you can make some simple editing commands, and Talon can press these keys way faster than you can, so it looks instantaneous. Let's put this back to its useful, fast state. Okay, just to demonstrate a few more features, you can also parameterize commands, which is very handy. For example, maybe I want to say hello to more people than you kind folks. What do? Oops. Right. So the angle brackets on the left stand for a phrase, an arbitrary sequence of words, and the curly brackets on the right are sort of splicing that into our string. Wake up. Hello, Mike. Rush. Hello, Joe. North, left, junk, crunch. Sometimes you do get misrecognitions. Once you're good enough, you can correct these without too much trouble. And we can answer some burning questions. Oops. What is 6 times 9? All right. So now that we know how to define voice commands, let's take a look at the thing we're trying to do, which is editing code. Wake up. Split wide buffer Fibonacci. Drowse. So suppose that I were, at the end of this file, and I wanted to delete these 2 lines, this branch. No more fizzing. Well, if I were using a keyboard, what I'd do is sort of hold the up key until I get roughly there. Oh, I had landed exactly on it. And then I'd press Control-K a couple of times to delete the line. So let's try doing that. We already have a command for deleting a line. Let's try adding a command for going up, pressing the up key. That's really easy. Go up, go up, go up, go up, go up, go up, go up. Delete this line, delete this line. Okay, that was not the best experience in the world. So Problem here is there's a delay between every command, right? And this is the problem of latency that I mentioned. Now I can somewhat address this by batching a bunch of commands together, like by saying go up, go up, go up, go up. This is kind of annoying. What if I could just say go up 3 times or go up 5 times? Well, I can. I can just define a command that repeats the previous command. Well, oh, I'm going to have to break that line, aren't I? Okay. Oops. The -1 is because we already did the command, so we only want to do it n-1 more times. Wake up. Go up 5 times. Go up 2 times. Delete this line 2 times. All right, so that was slightly nicer, but I still sort of had to guess or to calculate how many lines I had to go up and how many lines I had to delete, which is kind of annoying. And you'll notice we have line numbers like sitting right there. Why don't I just use the line numbers? So I'll define a command to go to a specific line. Go line. And this, at this point, this is just like me remembering how to tell Emacs how to do things. This would need to be different in different editors. There's a way to abstract out over it, but whatever. Enter. Wake up. Go line 8. Go line 8. Delete this line 2 times. Undo that. So, apart from the misrecognition, these always happen more during demos. This was okay, but I still had to guess the number of times to delete a line, and I still had to do 2 separate commands. I could have jumped them together, bunched them together into one phrase, but it's simpler just to have one command, where if I want to delete a range of lines, I delete a range of lines. Delete line 8 until 9. Another off by 1. I want to include the final line, so I need to move past it. Delete line 8 until 9. All right. So this is all right, and this is how a lot of editing in Talon actually gets done. Line numbers are very useful, and what we've just done is essentially reinvent a part of the Talon standard library of commands called uncreatively linecommands.talon. So you can see our delete line command right down here, and there's loads of others for copying, cutting, dragging line up, and so on. Okay, so you don't have to reinvent all this if you start with Talon. We've put some thought into it. However, there are limitations to line numbers. Buffer alphabet. For example, I here have a phrase that's not quite right. It should be Mary had a little lamb whose fleece was white as snow. How can I correct this? Well, one way is to use relative editing commands on words, kind of like go up, go down, delete line up, delete line down. So that would look like this. Clear word left 3 times. Say white as snow. Go word left 5 times. Go word left, clear word left. Run sheep. Clear word left. Run lamb. Drowse. All right, so that's all right, but it has the same problem that the line editing by go up 5 times had. It's still too slow and it still requires guessing. So how can we improve this? Go to sleep. We can improve this using the same technique. Line numbers were essentially labels that we could use in our voice commands. So let's label the words so we can use them in our voice commands. draft edit line. So here, every word has been assigned a letter label. And Talon has a phonetic alphabet, which I've put down here. You do not need to memorize that. And so if I want to edit a particular word or a particular chunk of words, I can use the labels. Replace each with sheep. Replace each with lamb. Select sit through crunch. Say white as snow. Draft submit. Go to sleep. Okay, so that was nicer, but it involved jumping into this other editor and then jumping back, so that sort of adds in time the thing that we gained. And it's not really a full-featured editor, this other thing. You'd kind of want a full-featured editor. So what I'm going to show you is what I think is the logical progression of this idea, which is a tool called cursorless. Buffer slides. Slide next. So you can think of cursorless as a spoken language for editing code. It's built on top of Talon and VS Code, so it uses a full-featured text editor. Created by a member of the Talon community called PokeRule. It's now a community effort. And one way of thinking about what it does is it solves this problem of per command latency. So how do we solve this problem? Well, we just use fewer commands, right? We do more in one command and we get it right the first time to avoid wait and try again and try again and try again. We've already seen one strategy for doing this, which is to put labels on things. Cursorless adds two more strategies, compositionality of commands and structure-aware editing. And rather than tell you what those do, I'll show you. Okay, here's a simple document. Instead of the letter labels, you can now see there's little circles over various letters. The idea here is to reuse the letters to stand as the labels for the words. So for example, if I want to manipulate the word hello, I use the letter H because that's what the dot is over. Take harp. So that's selected the word hello because harp stands for H and take means select. Take made. Take whale past yank. And putting these together, you can already do some nice editing. Chuck harp. Swap made with whale past yank. But so far, this is not much more than we saw with the previous demo. What's interesting about cursorless is it allows you to get a little more complex with your nouns. We're sort of doing verb noun. Take harp. Swap harp with whale. So our nouns are now going to get somewhat more interesting. Take first char harp. Take every identifier. So this is multiple cursor support. Every single one of those is a separate selection. And importantly, we can compose these things, first char and every. Take first char every identifier. So this lets you do some pretty interesting things, but this example is a little small to show them, so let's get back to the thing we are supposed to talk about, editing code. So here's our old example, and the thing we wanted to do was delete the else if error mod 3 is equal to 0 branch. Now the simplest way to do this is I can refer to that elif on line 7, the one with the green dot over the E, as green each. So because there's so many things on screen, we need colors as well as dots. So green each disambiguates it from the elif on line 9, for instance. Take green each. Take 2 lines green each. So that's one way of doing it. I could instead have told it to delete. Chuck 2 lines green each. But this is really underselling the capacities of cursorless because cursorless, the third thing I was talking about is how it's structure aware. So it understands the structure of our code. This means I can do some more interesting things. Take condition green each. So it understands that elif is a branch in an if block, And the condition associated with it is the thing that's been selected, error mod 3 is equal to 0. It also understands that it's part of a larger if statement. Take state, green each. And also, the thing that we're actually interested in is this particular branch of the if statement. So, Chuck, branch, green each. Undo that. Escape, go bottom. So this lets you do some actually interesting editing commands. For example, let's say I wanted to rename the variable a. One way of doing that is to select every single instance of it. Take every instance yellow air. Word current. Take every instance bat. Word next. So now we've done a little code refactoring to give ourselves more verbose variable names. We can also, for example, if we want everything to be fizzbuzz, we can just kill that condition and replace it with true. Change condition green sit, hammer true. Undo that. And finally, if we want to go back to plain Fibonacci, we can delete everything between that if and the print on line 12. Chuck sit until yellow pit. All right. So I'm not an expert cursorless user. In fact, I basically had to learn how to use it for this talk. I've been using Talon for a while, but I sort of stopped using it because my hands got better, which is a fairly common story with Talon. In some ways, that's a success story, right? You have a problem, you use a tool, the problem goes away. But in other ways, it's not so successful because it means the Talon community has a lot of churn, right? A lot of people come, work on it for a while, and then are like, oh, I can use my hands again. And because of those other ergonomic changes that most of us make, you stay being able to use your hands, right? Those ergonomic changes are much better at preventing you from getting a problem than they are from curing it. Yeah, it's, in some ways this is a success story, in other ways it's not. Emacs, buffer slides, slide next, drowse. So I'm afraid that's all I have for you today. I guess I talked faster than I thought because we have 5 minutes left. The main thing I wanted to show you is voice coding is practical today. This is not a hypothetical technology. This is not a coming in the future thing. And it's useful to people today, people who can't use their hands for whatever reason. It does, however, have some unique difficulties. We saw one of them, latency. That's the one I harped on because I think it drives a lot of the design of voice editing. It also has a pretty stiff learning curve. It took me about 3 months to get used to editing by voice. I think that's probably reduced now. When I started this, we didn't have a bunch of the things we do have now. For example, cursorless. Also, it turns out if you use your voice for 8 hours a day every day, your voice gets tired out. Same as your hands. We have problems doing things that would be easy on the keyboard. I showed you that we can do a lot, but we're limited by the accessibility APIs available and the fact that they're mostly not cross-platform. And as I talked about, there's a bunch of community churn. People join this because they're experiencing an acute problem. It helps them, their problem goes away, they leave. I think that this is really an interesting area for development because it requires new interaction paradigms, or at least it requires interaction paradigms that people have thought of and then didn't pursue. For example, structure editing we've been exploring that for decades in computers and it's never really been popular. The community of people who can't use their hands and need to use voice, it's a necessity, it's not a nice to have, right? We really need these high-level editing commands. Similarly, compositionality, even Vim has the ability to compose verbs with nouns in a simple way. So you can think of this as taking that idea a little bit further and into the realm of voice. And so I think there's really an opportunity to make a mark here if you're interested in doing research into these kinds of things, or in helping people out, or in just helping us develop the system. We are bottlenecked on developer time and community churn. If you want to talk about more, there is so much I left out of this talk. I left out stuff about how this is implemented. For some reason, that's the only thing that's coming into my head right now. I guarantee you I left out more. Yeah, I'm going to be at the Q&A tent. So, in fact, we have like 4 minutes. Should we do? No? All right, Q&A tent.